So I have an egg machine. What my egg machine does is well, I can't write egg machine. That's really bad. That makes me embarrassed. I actually have to fix that because that's just beyond the pale. All right, let's try again. Okay, egg machine. And the egg machine, the egg machine breaks 2.5 eggs every minute. So far, so good?
Mm-hmm.
Okay. How long until it breaks 4 dozen eggs? You with me?
Mm-hmm.
Okay, so the basic process is, what am I going to change into what?
The eggs.
So I'm going to change 4 dozen eggs, 4 dozen, and I'm going to turn it into what? This is how long is the question? What is my answer going to be?
How long? So time?
Time? Well, I got a unit for time. Give me a unit for time.
Seconds.
Seconds. We'll go seconds. That's a good thing. It makes it even harder. That's perfect. Okay, 4 dozen. So, what has to go on the bottom? This always has to match.
Mm-hmm.
Has to match. Now, what can I turn a dozen eggs into?
1 dozen.
Is?
And then the top would be
1 dozen egg is equal to
12.
12 eggs. Dozens cancel out. Now I'm in eggs.
And then use that one up there, 2.5.
2.5 eggs. I have to put eggs in the bottom because I want it to cancel out. Is 1 minute.
And then 1 minute is equal to 60 seconds.
60 seconds.
And that's it, right? And then you just multiply straight across.
Right.
Or like divide and stuff like that, yeah.
Yep. So we're going to multiply 4 times 12 times 1 times 60 divided by 1 divided by 2.5 divided by 1.
I got that.
Okay. That's how unit conversion works, right? As long as you cancel out the unit at the bottom, you make everything in equals to, you're fine. Now, the one that comes up in our class is change 360 kilometers per hour into meters per second. Now, we have to do that because we like everything in meters per second, right?
Mm-hmm.
So the first thing I'd recommend doing is we don't write it like I just did. We're going to write kilometers. We're going to put hours in the bottom so we know where everything is. Okay?
Yes.
All right, what do you want to convert?
The hours first.
Hours first. So where am I going to put hours?
On the top.
On the top, because it has to cancel out. Now, what can I turn hours into?
1 hour and 2 minutes.
1 hour is how many minutes?
60 minutes.
60 minutes. Crossing out my hours. Now I'm in kilometers per minute.
And then don't you have to do 60 minutes into seconds?
Will we do 60 minutes? What goes on top?
1 minute.
1 minute. And 1 minute's how many seconds?
60 seconds.
60 seconds. Now I'm done with minutes. I'm in kilometers per second.
Okay, and then that's where you do kilometers
on the
the
bottom.
bottom.
Kilometer has to be on the bottom, and then you look up the unit on the little chart. It says 10 to the third.
And then
And
you just
you just multiply then.
10 to the third here. And then you go
times
360
and
times 1 times 10 up caret 3 divided by 60 divided by 60. Boom. I just
That'd
did
be
it
that'd be
wrong.
100 meters.
That was dumb. I can do this in my head. What'd you get?
100.
100.
100 meters per second. That's the correct answer.
There was
one.
Hold on.
Hold
Let
on,
me
let me
try to
try
find
to
it.
find
Sure.
it.
It's because the thing
the
that
thing
I'm
that I'm
confused
confused
on
on
is like,
is like, how do you know that
you're
you're
supposed
supposed
to
to
convert
convert
days
days
into
into
seconds?
seconds?
Well, so the question is, what's its angular speed?
Mm-hmm.
How are you going to find its angular speed? What is angular speed?
I'm not sure.
Angular speed is how far it goes in terms of angle divided by the time it takes to do it, correct?
Mm-hmm.
So you should know the following, although it's not a requirement yet, you know, for the class, and it will be a requirement by the end of the year, and that is that the Earth goes around the sun, right?
Mm-hmm.
How long does it take to go around the sun once?
Wait, can
Wait,
you
can you
repeat
repeat that again?
How long does it take to go around the sun once?
Then
that's
where
where
you have to do like the days into
seconds.
seconds.
No, I just need to know how long does it take to go around the sun once?
Oh, 1 year?
1 year.
One year. Good. I love it. 1 year. Now, problem with 1 year is we do everything in seconds, right?
Mm-hmm.
Mm-hmm.
So I need to convert that 1 year into seconds. How am I going to do that?
Converting
1 year into days.
1 year into
Days.
days, and then
How many days in a year?
and it's
365.
365 days. Now I'm in days. How do I get days into seconds? I need to get there.
That'd be 1 day.
That'd be 1 day
equals 24 hours.
equals 24 hours.
Now I'm in days, but I'm not yet. I'm in hours, but I'm not in seconds. How do I convert that?
Then
That'd
be
be
1 hour into
1 hour into
60
60
minutes. I love it. Now in minutes.
And then 1 minute into
60 seconds.
Woo! We finally made it to seconds, which is what we were looking for to begin with. So 360 up there, 365. No. Oh no, I melted my calculator down. Let's try this again. Oh, no. So, 365 times 24 times 60, and I get a big number.
you get
31
million.
million.
31,536,000 seconds.
Yes.
All right, that's what we got for seconds. Now, that's our seconds. Now, that doesn't answer angular velocity. Angular velocity is how far you go in terms of angle divided by time it takes to do it, right?
Uh-huh.
So how far do I go in terms of angle? If I go one trip around, how far is that in radians?
It's
1.49.
49.
No, that's the radius of the orbit.
Oh, then
Angle. One trip around is always what in radians? 2 pi. So I would say, I'm going to use the W for angular velocity. You don't have to know that, but that's what we should use. 2 pi divided by that awful number would be my angular velocity, right? Because it's what angle I do divided by the time it takes to do it.
Mhm.
So I'm going to go ahead and divide that out.
Wait, can you say that
Wait,
again? How
can
long?
you say that again? How
It's the
long?
angle, how far I turn. In this case, you said 1 trip around, so that's 2 pi, divided by the time it takes to go around that distance, right?
Yes.
So we do 2 pi
Yes.
divided by that big old awful number you just gave me earlier.
Okay.
Okay.
And then that would be.
And then that would be
Um. That'd be
Radians per second? Okay. That's okay. All right, now that I have angular velocity, how do I find linear velocity? How do I turn an angular thing into a linear thing?
multiply
By the
by the
time.
You turn an angular thing into a linear thing by multiplying by its
distance.
radius. Always radius. Angular to linear, you multiply by its radius. That's why I gave you the radius, right? It's right there. All right. So angular velocity times radius gives me linear velocity. So the angular velocity is this awfully small number times my radius, which is an awfully big number, because we're pretty far from the sun, and that's a good thing.
And that's how you get the linear.
That's how you
right?
switch it to normal velocity. How fast are we really going? How fast are we really going?
$29,800
Meters per second. By the way, that's why we're afraid of asteroids, because if an asteroid was stationary, we'd hit it at 100 times the speed of sound. And they're seldom stationary, so that's bad.
Okay, now
I get it.
All right. Remember, that's a weird problem. That's intentionally a weird problem.
And that's all we're gonna have on the test, right? Like the radius, converting and stuff like that,
and then the